Well, good evening, guys. How are we doing out there?
Great, man. Doing awesome.
So welcome to our first live stream. And tonight we're going to be talking about CircuitPython. So we'll start off kind of interesting format. We're going to start off with just a little information about some new topic or subject. And then after that, we're going to go ahead and let me mute my other computer here. We're going to go ahead and do some question and answer. Talk about projects you might be working on and new and exciting things that are coming out. You got any questions? Hit us up on the YouTube. And yeah, so let's get started. Charlotte IoT obviously is totally awesome. We are a group of people who are just in love with everything that is connected to the internet and making everything else connected that's not right now. Definitely a to-doers group. A lot of fun. Got a couple good words, couple good sponsors out there. Shout out to Riot for posting this out in Atlanta and Raleigh, giving us some, a little bit of viewership in those areas. We also want to take a moment to thank Dan. Dan's our fearless leader. Welcome, Dan.
Thank you, Jeremy.
And Dan's company, not his company anymore. Dan works at Pratt Miller, doing awesome and amazing things. Doing a lot of ML stuff these days, machine learning and new indoctrination into Python, which is really, really cool. So did you hear about Jupyter CircuitPython notebooks? Will you be using them tonight? Mike, I'm not quite sure we are not. So let's see. So let me figure out how to get this there we go. All right, so there's my CircuitPython board. So CircuitPython was, if anyone knows anything about Python, it was ported to microcontrollers and is now Micropython. And ADA Fruit being as awesome as they are, they took it a step further. And they were like, well, let's throw it on microcontrollers, but let's make it ultra friendly to use. So what they did was they went through and they added, they ported Micropython, and then they added some cool feature sets. Beyond just the standard, hey, we can blink this, we can do that. Most of the devices that ADA Fruit sells nowadays have CircuitPython libraries for them. And that is really, really cool because it allows you to, buy a device that is reliable, because we know they test everything before it goes out the door. And then also allows you to go ahead and you've got a community behind it. You've got all that help behind you, making it all work for you. So it's really, really awesome what they've been able to accomplish with that. As you can see, I'm going through and every time I change the, you see my board here. This is a Pi portal. This is a Pi portal. And we're making some changes along the way. And every time I do, you can see it's going to advance the screen. And when it's advancing that screen, it's automatically rerunning the firmware for us. So it's really cool way to get your code working. You just go in and you make a change, and bam, it just starts, working. Every time you make a change to the code itself, it just goes ahead and reloads all the libraries, resyncs, and goes forward from there, which is really, really awesome. It's really, really awesome. And one of the other awesome things about this is that they are coming out with support for the new ESP32 S2. I don't know if anyone's seen that. One of the things the Pi portal does is it uses the USB port, and it has to be an integrated port. So it has to be built onto the controller. You can't use something that's anything that's using like the USB to serial chip. It's got to actually be built onto the controller. And the ESP32 and the ESP8266, kind of our favorites, low cost Wi-Fi devices, don't really fit that. They don't fit that bill. They don't have that built-in USB. But the new ESP32 S2 does. And so they're madly creating the framework to be able to do Bluetooth and Wi-Fi from within in that device itself. And that'll be the first Micropython device that actually has Bluetooth and Wi-Fi built in. Among some of the supported boards for them, they have a number of smaller. They have a number of smaller boards, and let me grab a screen here and we can take a look at them. They have a number of boards available, and you can see Seed has come out with a couple different boards. This is their new YO terminal, although Bluetooth and Wi-Fi isn't supported here. The M4 Express is about their flagship. It's the fastest of the boards, and then the Trinket M0 and the Circuit Playground Express. Those boards themselves are pretty capable, but just a lot slower. You have the new Clue, which is basically a drop-in replacement for the. Oh shoot! What was the board they gave away in the UK? The Microbit. Only with the color LCD screen. The Pi portals are really cool. Touchscreen interface with a touchscreen interface with built-in Wi-Fi support using an ESP32. You've got an itsy bitsy M4 in case you need a little bit less, in case you need something a little more compact. And there's actually a daughter board for this that's ESP32, so you can. It's called Airlift, and you can use that for Wi-Fi. So it makes that pretty good. There's a Pi Gamer control, so you can build that out. and play games. The Neo Trellis is it's an RGB LED display, and it's got sound support. It's got a huge amount of memory, USB. Unfortunately, the only thing bad about it is you can't hook up a Wi-Fi controller, so it's not Wi-Fi. They've got an M4 with the airlift, the Wi-Fi, and the Pi Portal comes in 3 different sizes. This is a small one. This is the big one. And then a number of different devices made by different people are also supported. So there's a ton of support out there for. That's an awesome board. There's a ton of support out there for all of these devices, and they just keep adding more and more all the time. So. So with that, programming is pretty easy. Basically, you just it shows up as a drive on your computer, and then from there, all you have to do is grab modify your files, whatever you need, and it automatically, when you save it, automatically updates, reinitializes the code, and gets you up and running. So. Really, really fast and quick to use. Obviously, wow, a Python-powered Game Boy compatible cartridge. That looks cool. There's also native support for some of the Bluetooth chips out there. So the NRF 52840, which isn't a bad chip at all. And you can even take the you can even reprogram a Xenon from Particle for CircuitPython, which really makes them kind of useful now. So questions out there? So different projects you can do with them. I've got to clean up the drive in this one. Used a little bit too much of the drive space, and so trying to figure out how to get some drive space free, so that I can go ahead and put in the files for the this is a weather station. So it's a weather station code. I think I might have it. And then you can also add the new bootloader code in. You just double tap the power, and it goes into bootloader mode, and it just shows a different drive letter, and just drag and drop the bootloader. It automatically updates. It's really, really phenomenal how easy it is. So, questions out there? If you're on the live stream, you can type There's a little lag for the live stream, so if you type something, we normally don't see it for about another 10 seconds. Which one did you say were Wi-Fi enabled? Robert was asking. So they use something called Airlift, which is a firmware for the ESP32. And the devices, probably the device you'll find most useful is a Pi Portal. They go for around $50. They're about $60 if you get the larger one, which is what you see me with tonight. There's also a standard Arduino format board, and that's the M4 with an Airlift chip on it. So this looks like a Uno board, pin for pin, pretty much the same. Obviously, it runs an M4, pretty powerful. A lot of memory, a lot of flash. And then it's I don't know if the Pi Gamer has it as well. And then there's also the Airlift. So available just as a separate chip. And so this is just an Airlift Featherwing. So if you were to use an M4 Featherwing Feather, and then you could add this to that as well. And then there's just a coprocessor board, and there's a drop-in Arduino shield. And so you can use those. You can use those as well. The Arduino YO terminal has Wi-Fi built in. It also has Bluetooth, but there's no code available for it. And that's the same thing with the ESP32 S2. It's got Wi-Fi built in, but they don't have support for it yet. So it'll be a while before they do. But the Bluetooth support, I will tell you, is pretty outstanding. They've got libraries that work both in Linux and on the CircuitPython board. So if you wanted to communicate with a computer, it's pretty easy to go back and forth. So they've really done a lot of good work there. So. Pi Badge Airlift. I know what this is. This is a new board they're coming out with. And the Boron has support. There is a library for cellular support. I didn't realize the Boron could be modified for this. That would be interesting. There is, by the way, unfortunately, no one has really come up with a good way of doing over-the-air updates for these. And so that's one of those things that that's one of the things that will be interesting to see how they conquer that moving forward. So with the Airlift, that gets pretty tight to figure out how to get the software down. Although you can write to the drive, so you could pull a file and write to the drive, and it would reboot and run that. But there'd be no it'd be hard to do like a failover if the new code didn't work. So other questions, projects, things you guys have been working on? I was going to ask too, a couple of people were saying that we might want to change the time to something like 4:30, 5 o'clock. So it's right after work. I'd be interested in what everyone's going to say about whether, what that, what you guys think about maybe changing the time. So we'll go into a couple other boards that they've got. The Circuit Playground Express, if you order from ADA Fruit and you spend more than $300, they send you one of these bad boys for free. And we've actually done some really cool training with them for the kids. But they're really awesome. They've got NeoPixels on them. They've got an accelerometer, tap detection, the light and the temperature sensor. They've got a microphone and a little speaker on them. A couple buttons. Obviously, I2C and a UART. And they run a Cortex M0. So pretty powerful. They also can be connected to USB, or you can connect a battery to them. So they're pretty dead useful. There's also Arduino libraries for this too, and there's some make code online, so you can do block programming if you want as well with it. So how does CircuitPython compare to Micropython? The CircuitPython, I would tell you that it's probably a little less stable because it's a smaller group of people working on that, but it's a port of MicroPython, so they can still pull in MicroPython features when they want to. A lot of the CircuitPython, the guy who does the most developing on CircuitPython would tell you that it's probably not production ready. But having seen a lot of production code, I'm not quite sure that you couldn't use this in production and be perfectly happy with it. So take a look at some code here. Here's some great examples of how CircuitPython works. Oh, so one of the really cool things is that there is a testing in production. Yeah, I would agree. Coming from the ESP8266 and the ESP32 perspective, it's probably, yeah. Arduino has a camera with more off chip than Raspberry Pi. Yeah, very, very true. So which has more coverage? You're talking about the difference between Micropython and CircuitPython. I would tell you that Micropython has more coverage because it supports a lot of boards that don't have an onboard USB. One of the things that and this isn't true because there's a CircuitPython version 3 is available for the ESP8266, but when we where is the weather station? They dropped support for it, and this has got some really cool code in it. They dropped the support because it didn't have they dropped support because it didn't have an onboard serial port that was. They couldn't do a lot of what they wanted to do. CircuitPython is used best when you can connect it and it allows the device to act as a USB drive, and then you can use that for you can use that to directly edit the code on the device. So let me see if I can connect. So typically you would use something called MU, which is a very, very basic type of a very, very basic why is it trying to come up with a keyboard? It's a very, very basic form of like an editor. Huh. That's the wrong one. Sorry, guys. So this is MU and pretty simple to run. Sorry, I didn't know, guys, but we can't do screen sharing on a PC under Chrome with StreamYard, so have to do it on my Mac. Costs more too. Or do we know it has a camera with more off chip than Raspberry Pi? So Dan was asking if any of these take video input. No, unfortunately. CircuitPython doesn't do anything with video right now. Whereas like an ESP32 can definitely do, can definitely work on video. In fact, you can stream, you can build a webcam out of an ESP32 and a camera. Let's see. There is a real-time. There is a read, evaluate, print loop. So basically, it's a real-time interface to allow you to communicate and write Python in an interactive format, right? So like a live interpreter would allow you to do. And that can be really cool for if you want to, if you want to do any kind of, programming or testing of some code really quick. You've got all your libraries there. You can write it out. The only thing is it doesn't save anything in that mode. So the board itself, sorry, I'm trying to get the MU editor up and going. Somebody's replacing the main board on his 3D printer right now. Joshua, what you changing out, man? You there with us? Kind of curious what you're going from and what you're going to. Replacing the stock Ender 3 board with the TH3D Easy Board Lite. Nice. Yeah, that's a nice upgrade. So how many people here have a corporate Mac? That would be me. My Mac's not letting it, my Mac's not playing nice. My Mac's not playing nice with MU because it's not signed. So I apologize. I can't share the screen on one system, and the other one I can't run the MU editor. So we'll have to take a look at this later. As far as the code goes, though, let me bring up some of their GitHub stuff and show you. That's anticlimactical. It's empty. So here's the PyPortal. And we can see in here it supports BMP files as far as pushing everything to the screen. The PyPortals have a touch screen, which is really, really cool. But if you're used to working with Python, I mean, this is I think it's as easy as it gets. Dan, what do you think?
It looks pretty cool. Yeah, I'm curious what you can import.
So there's a ton of libraries for CircuitPython. You can pretty much guarantee that anything that ADA Fruit sells, there's going to be a library for it. And it also, most of your displays, I was really, there's a RA, I think 8775 display that I'm really fond of. They've got a nice 7-inch touchscreen, and that's got support, motion sensors, environmental sensors. I mean, there's just a ton of support out there for a ton of things. You've got support for LoRaWAN, both the RMF 95 and the 69. This is really cool. The ESP32 has code that runs on the device itself, but then there's also firmware. You can burn it to an ESP32 and make your own airlift, which is way cool. And obviously you've got the Bluefruit. As far as I/O goes, I mean, you're talking about a ton of different items, including, ADCs and DACs, PWMs, all kinds of, motors and user interface. It has, if you were going to implement a touchscreen, it has display buttons, which are really cool for doing touchscreen. So you just basically build out a touchscreen with the display buttons. So obviously it supports NeoPixels, and it also supports a whole bunch of not only NeoPixels, but it has like a bunch of different display libraries, different ways of different mixtures of lighting and stuff like that. Supports AWS, Azure IoT for Dan, and obviously MQTT support, not just for ADA Fruit, and their ADA, ADA Fruit IO. But you can use it to connect to most anything, except the big IoT providers, right? So AWS IoT normally requires a cert. They've got a separate library for that. Obviously it supports, anything HTTP, but there's just a ton of support out there. I like ADA Fruit devices, so a ton of BLE devices it supports, heart rate monitors, cycling speed and cadence service. Okay. So just a ton of stuff out there.
Sweet. All the rich debugging that you normally get from Python, it all works.
Yeah, and the other thing too is the screens themselves. So you've got the serial connection coming out, and you can pipe things out to the serial connection over USB. But the other thing is, like, if you look here at my, if you look at, and I'm sorry, my camera's kind of bad, but if you look at the screen itself, right, you're going to see on these, when they boot up and error out, it's going to show you the error right there. So see if I can get this to. Is there enough pixels in that camera? No. So it'll display the error message on the PyPortals. And these are pretty robust. The big ones have everything but a temperature sensor, but there's even a little ambient light sensor in here, right? And then you've got their infamous connectors on the end. So if you want to just connect right to it, you've got your connectors there. SD card slot on the back, right? And as you can see, there's an M4 back here. And then there's an airlift, which is actually an ESP32. So pretty sweet. So other questions tonight? Anyone got questions about projects they're working on? Things they want to show off? Cool and interesting things going on? Dan, you were talking about the touchscreen display.
Mm-hmm. Because normally with Python, when you have a display, Python's the back end, and you have to have another framework on the front end. We played with things like Kivy and things, and then it's really hard to debug. So I was curious, did Adafruit make their own like UI layer? And it sounds like they did for the buttons and things like that. And are you able to debug while you're using the touchscreen, or how is all of that?
So this is a library, and one of the cool things about their libraries is, if you're used to working with their Arduino libraries, when you roll over to the CircuitPythons, they're pretty much one for one. So you get a lot of the same functionality automatically. But so this is a button, and obviously it's got an X and a Y, a width, a height, a fill color, an outline color. You've got a label and a label color, and then obviously a name. And then what you're doing is, this is just asking what point you're using, what point on the screen you touched. And then each button you can call something called contains, and it'll tell you whether you've touched that or not. And then you store basically a state of whether the button you pressed is currently touched or not.
Looks pretty cool.
Yeah, so it's actually, I mean, this is it. This is for a touchscreen, right? So if you were to drop this, on a PyPortal,
so basically buttons and labels and probably some other UI types of controls too, lines and stuff.
Oh yeah, so that's so CircuitPython's graphics capabilities are, the way that works is, you basically have a text, just like you have in Arduino, where you basically inherit the board, the driver, and the driver does simple things like you can override drawing a line if you want to, if there's a faster way to draw a line. Otherwise, the library will just draw points for you. And so there's a lot of abstraction there. You can, your driver library can override a lot of the base functions of GFX. And then GFX allows you to have a standardized interface that does like lines and circles and boxes and fills, and all of that is abstracted away to a graphics layer. So you don't control the board directly or the controller for the LCD directly. It's done in the graphics library, and the graphics library pushes everything out. So handles all of your fonts and everything. Real easy to use. And so basically you have there's a ton of drivers out there, right? So you pair these drivers. Those aren't drivers for LCDs. You pair those drivers with yeah, here we go. So you would pair a graphics board driver with GFX, and it would work that way. So, and then there's standardized fonts that you can use, and there's a ton of fonts out there. You just drop the font file into your either you would do you include a .h, or here you would just add a font file and it would read it. But you can see, there's the basics are there. Circle, line, triangle, pixel, rounded rectangle.
Looks really cool.
Yeah, so it's real easy to do. If you look at like if you look at like I've done some stuff in it, and it's actually really easy, and it can get really complex really quickly. But I can show you actual code. So it's the same. It would look the same pretty much in Python as in C.
Mm-hmm.
But this is Skynet. This is my cellular controlled power controller. But you can see when you make a button, this is your button initialization, right? So really simple. And then it has a function that allows you to say whether a button has just been pressed or not.
Mm-hmm.
And then that's how you handle a lot of the actions, is just by saying, hey, so we're going to tell it that this button has been pressed. And there's actually in this, when you press a button, it'll if you set the button to be pressed and then refresh the button, then it'll automatically change the background color for you. So it has that ability to automatically change to look like it's touched and not.
Sweet.
So yeah, it's really cool. It's really pretty awesome how that works. So, and then obviously if you were just going to do, I mean, this is drawing the screen, and as you can see, it's setting a cursor, text color, text size, printing things, coming here, adding some more text, no big deal. This is all pretty straightforward and simple to do. So, yeah, pretty easy. Now, you guys were talking about how long it takes to, Josh Garrison, I see you have a question. LED library question. What you got, boss? Craig's over here programming his ESP32s at warp speed. Use Visual Studio, and it's slow to convert, and hit some caching on the build. Interesting. They do make Visual Studio for a Mac.
Yeah, Visual Studio Code. Oh no, there's one special for Mac.
I thought so. I don't use it. I use VS Code. What's the difference between WLED and Fast LED? So Fast LED's claim to fame is that it's fastest. I mean, it's designed to be, it's designed to really push out data very, very quickly, and it's supposed to be the fastest one out there. The difference between that and WLED is WLED basically sits on top of Fast LED, right? So WLED is more of a wrap for Fast LED, and oh look, they got an Android app, an iOS app, and this is abstracting away control of those LEDs. It also has different. So if I was to write something in Fast LED, I would have to bring my own so this is something written with Fast LED, and it's cool, but the problem is I have to write functions for, like, this is a function to display fire, right? And this function randomly generates fire, what looks like fire on an RGB LED. WLED would have that and other effects built in, so that you could just go ahead and you could display things. So oddly enough, when you're talking about LED libraries, the NeoPixel library is probably the most heavily used, because ADA Fruit uses it on a lot of their stuff. And so Fast LED can sometimes lack support in certain areas. For example, there's no Fast LED for CircuitPython, but the NeoPixel library works. So yeah, Greg's got a good point about excluding antivirus from build folders. I can't tell you how awesome that is. Is it kind of like it's Greg? I'm going to tell you it's not really a wrap, and the biggest it's not really a. So GFX is a way of abstracting a bunch of different LEDs, a bunch of different LCD drivers away from the user and adding a common interface between the two. While WLED is specifically meant to wrap fast LED, right? So you couldn't put NeoPixel library in there. You couldn't put a library to do one of those fast graphics panels that's got the 20-pin connector on the back. So most of my LEDs setups on fast LED. Joshua, what I would do is I would, from just make a switch and know how to do both. That's kind of what I've done. I can run fast LED and I can run NeoPixel too. So I just kind of switch between both of them depending on what I'm doing. Or more to the point, whose code I'm stealing. So we're reaching about the old 8 o'clock time frame. Curious if anyone's got any other questions, any projects they want to share. I'll make sure to prepare a little bit better next time. Now that I know the capabilities of the software we're using.
Yeah, this was great, Jeremy. Thank you for sharing with us.
Yeah, no problem. So next week we've got AWS coming, and they're going to show us green grass again. So that should be pretty cool. I've been asking them to show us not only green grass, but also looking at the CloudWatch logs and understanding how to troubleshoot a lot of the AWS services. I think, Dan, you're probably familiar with all the different ways you can troubleshoot Azure stuff, and it's often one of those things that nobody talks about. They show you the cool thing that works, but they don't show you all the logging that can be done or all the metrics behind it. So that's one of the things that they're definitely going to be covering too. So
sweet. Yeah, that'll be epic. I'm curious too about green grass because I used the older versions that
right.
I think they've made big improvements on it.
Well, yeah, Lambda on the edge too. So, that's always really cool. So, and then after that, so we're back in 2 weeks with an online venture. Yeah, so if anyone else doesn't have any questions, we'll give a shout out to Dan, our fearless leader. And Pratt Miller, who does a great job of supporting us. The Riot Group, who is an excellent partner of ours. Thank you for cross-posting this. We definitely appreciate the love there. And if anyone's got any questions from now and then, feel free to drop a message on the live stream, and we'll hope this recorded. If it did, like it should have, we'll post it online. So, all right. Well, if anyone doesn't have any other questions, we'll go ahead and sign off for the night.
Awesome. Thank you very much, Jeremy.
Yeah, Dan, thank you. Y'all have a good night.
Good night.